kinetic theory of matter. Of course, the word kinetic means moving. This basically says that all matter at the atomic level is in motion. These atoms are jiggling, moving back and forth very rapidly. The more energy that it has in the matter, the more they are jiggling back and forth. And in fact, it is the motion, the kinetic energy, the amount of jiggling that we measure as temperature. As I add energy to it, say if I had an ice cube or a solid, as I add energy to it, then as I add energy cannot be created or destroyed, and so the energy is transferred to more kinetic motion. It makes them start to jiggle faster and faster and faster. Eventually, they will start to jiggle fast enough where right here is a solid, they're holding hands, they're kind of locked in place. That's why a solid doesn't move. Every atom is locked in with its neighbor. As I add more and more energy to like an ice cube, it starts to jiggle fast enough where they can't hold hands anymore. They start to slide past each other, and that would form a liquid. If I was to keep adding energy from my heat lamp to the liquid, they would start to jiggle faster and faster and faster. You'd eventually start to see the water boiling as you did that, and then it would start to enter the gas phase as they're moving so fast that they're bouncing off each other that they start to leave the liquid state and start to bounce all over the room. And so the more energy you add into it, the more the motion of the molecules. But solids, liquids, and gases, they are all jiggling. These are just not jiggling enough to let go of their partner's hands. There is a number out there called absolute zero. It doesn't exist in the known universe that we know of. But that is where you remove the energy. As you reduce the amount of energy, things slow down their jiggling. As heat energy leaves the liquid, as I remove the energy away, well, energy can't be created or stored, so these don't have as much energy. They're not jiggling as fast anymore, and they will return to a solid state. So it's actually removing energy. When you cool something down, you make things jiggle less. And if you get it all the way down, the coldest temperature we have is this thing at 0 Kelvin called absolute zero. And that's when all the motion in the matter has been removed and there's no more jiggling. But it doesn't exist that we know of. Everywhere we look at in the coldest, deepest, darkest coldest places of space, it's always about 1 to 2 to 3 degrees above absolute zero. And that's some of the leftover energy, we believe, of the initial Big Bang explosion, the remnants of that. There's still some energy out there.